And as of up to last year, I had 35 years of experience working for the province of Ontario, not the city of Ontario, the province of Ontario with the Ministry of Transportation there. And two of the roles that I held there were head of our asphalt group and head of our construction group. So from that, I hope to bring you some perspective on some ways that we can address some of the sustainability challenges that we have today related to highways and particularly pavements. The title of my presentation is Sustainability with Clean In Situ Thermal Regeneration Technology. And if that seems a little bit technical, perhaps that's because it is, but hopefully through the presentation we'll all get educated, and hopefully at the end of this presentation you're going to really love and be excited about pavements and asphalt technology, because that's what I really love, and I hope I can share some of that love with you. Here's a quick outline of my presentation. I'm going to give you some background. I'm going to give you a little bit of Asphalt 101 lessons. I'm going to then go into the sustainability of asphalt and tell you good news stories and bad news stories. And then I'm going to talk about that in situ thermal regeneration, also known as hot in place recycling, and then the next generation of hot in place recycling technology, and then some closing remarks. So, as background, I think you picked up that I'm a pavements construction engineer, but more than an environmentalist. However, let's put some context to this. And you know, in terms of sustainability, there is the United Nations Paris Agreement, which nations have signed on to, and it's to address climate change, which is a global emergency. Emissions need to be reduced by 45% by 2030 and reach net zero by 2050. So that's not too far away, and that's a commitment of the countries that have signed on to this Paris Agreement. This requires governments to take bold and immediate steps towards reducing those emissions now. Another United Nations sustainability group, different from the other one, is sustainable consumption and production. Our planet is running out of resources, and governments need to implement and enforce policies and regulations that include promoting circular economy practices and supporting sustainable procurement practices. So why are roads important? Well, because we spend a whole lot of money on highway infrastructure. They're considerable. This graph tells you, this is Federal Highways Administration, so it's all for all of the U.S., all of the various funding levels, government funding levels are spending. You can see the top line there. I think that's orange, is spending as of 2022 $128 billion per year on highways. And then there's some other highway expenditures here that are related, but the big one is there. So $128 billion a year. There is some really good opportunity there if we can bring some sustainability into our transportation or highway expenditures. So that's the good news. Even better for those of you that are in government, when you look at that, that is, depending on your level of government, you're making considerable expenditures of your budget for transportation and highways. Likely not your largest expenditure, but one of your biggest ones. But if you look at it not as expenditure, but as procurement, this is probably your largest procurement expenditure, because of that $128 billion, I would say 95% of that is procurement. Hiring construction firms to rehabilitate your existing roads or build new roads. And let me put that in perspective. We're not building that many new roads. We are pretty much spending the majority of it on rehabilitating our existing roads. So, and that's all procured through most of it being open tenders to do this work. Versus some of your other expenditures, which are going to pay teachers and stuff like that. A very worthwhile expenditure, but something that doesn't provide the same sustainability improvement opportunities. Asphalt, don't we just love it? Asphalt pavement industry facts. Approximately 420 million tons of asphalt were produced in 2019, the last year. I'll give you some more data from other years, because I know you just want to hear more about that. That'll come, so stay tuned. 94% of the paved roads and 80% of the runways are surfaced with asphalt. So it is a major material used for the pavements. And this is for America. The asphalt industry has a record of using sustainable and environmentally friendly practices, so that's good news. Asphalt pavements are recycled into new roadways at one of the highest rates, over 90%. So again, this is good news. The asphalt industry tells you this is good news, and it is good news. Like, you know, we recycle those pavements. That's great. However, let's take a closer look. Reclaimed asphalt pavement is asphalt material that is reclaimed from the pavement, either through a milling machine that grinds up the existing roadway and takes it back to the hot mix plant, or full depth removal, where a backhoe or an excavator removes that asphalt in big chunks, sticks it on a truck, takes it back to the asphalt plant. RAP is approximately 95% good quality road construction aggregate and 5% asphalt binder. That's the black glue that holds it together. These are valuable materials for reuse. There's nobody wanting them to put them in a landfill. Why would you want to do that? The aggregates are good, and it's got asphalt cement in it as well. Why not recycle it? And that's what the industry is doing. The average percentage of RAP used in asphalt mixtures is 21.1%, so approximately 20%. So that's good, but what about that other 80%? And with that percentage of 21%, the RAP stockpiles continue to grow across North America. So again, continuing to take a closer look on some of the maybe not so good stuff that gets lost in this message. And again, what I've told you is all true, and it's all to be commended. But at the same time, you know, a significant portion of asphalt pavement is downcycled into a lower function, such as the granular base material underneath the asphalt layer. And you can kind of see that here. A typical asphalt pavement is some layers of asphalt over some granular material. That's how roads are built. And so some of it is this occurs either by taking RAP that is milled, taken back to the plant, mixed with granular material, and then put out during construction, or through a process called full depth reclamation, which I'm going to educate you about right here. It's basically a big milling machine that goes there, and it takes your old distressed pavement with lots of cracks in it and basically pulverizes it into chunks of wrap or asphalt like this, and mixes it with that granular material, and then behind it, it's all regraded up and compacted nicely, and it makes good base material. But unfortunately, you're now using it as a granular material, not as an asphalt pavement. That's a lower function where you're taking higher quality aggregates that should be used in asphalt and using them as base material, which doesn't need those high quality aggregates. And you're getting no benefit from that 5% that was in there, that is your asphalt cement liquid. And you know, I can tell you aggregates are not that expensive when you compare the price of asphalt cement or the crude oil component. That stuff is expensive, and it's such a shame that you're not getting any use to it. So I'd like to think that we can do better. So again, continuing to take a closer look at things. The asphalt paving industry created 21 million tons of carbon dioxide equivalent emissions. And here is those trends on this chart. And looking at the yellow bars, that's your emissions, and the axis is labeled on the left-hand side of that chart. So there's your emissions from 2009 to 2019, and the green line is the amount of total hot mix produced in North America. And you can see it's kind of flat with an upward trend. So coming back to one of those earlier slides where we're going to meet, I think it was a 45% emissions reduction by 2030, there's some smart people in the room here that are smarter than me. Because quite honestly, if you're asking me how this trend line here with the yellow bars on emissions is by 2030 going to get you a 45% reduction in emissions, I'm not sure how that's happening on our current course of doing the same thing over and over again, just hoping that magic line will, or those bars will stop dropping. So doing what we're doing isn't going to get us there. So we need to do better. So that comes to hot in place recycling. Isn't this great? And more education on asphalt and pavements. So hot in place recycling is a single in place process where out on the road, equipment comes and it heats the existing distressed pavement, and that softens it up. And then that soft pavement, that hot, soft asphalt is then milled up, and then it's taken and it's remixed. That existing pavement that's milled is remixed with some rejuvenator, and that rejuvenator takes that old asphalt that may be 25 years old, and you know it's hardened up. It's a harder base material. It's been softened because you heat it, but once it cools down, it will be hard. So you add in a rejuvenator that sort of softens and re-energizes the asphalt cement in there, and then you run it through a paver and compact it, and you've got a rehabilitated roadway to drive on. That's all done in place. Versus the other typical process, which is, we call it in the construction industry mill and fill, where you go, and you can see on the left there, that's a milling machine, milling up the existing asphalt pavement. Then you have to take that wrap material obtained on site, you transport it back to your hot mix asphalt plant. You know, in Canada it's maybe 10 kilometers away. Here it's probably going to be 6 miles away. Anyways, and then at the asphalt plant there in the middle, You then take 20% of that reclaimed asphalt pavement, or on average, you mix that with all new material, heat it up, mix it together, and then truck it back to the paving site, and you run it through your paver. And for each kilometer that you reconstruct, there's 50 loads going to the plant and 50 loads going back to the paver. So to put that in perspective, there's a lot of, and then you're using new material that has to be trucked in from a quarry or a pit. So just to give you some perspective on comparing the two processes. So what are the advantages of hot-in-place recycling? Well, the first one's one of my favorite green reasons to use hot-in-place recycling. The cost is significantly cheaper than conventional hot mix in the conventional process of milling and filling. The cost savings can be from 30 to 50%. That's my favorite type of green, and that's, and it's one more great example of how being green and sustainable can be cheaper. Some of the more environmental sustainability aspects is it saving on new materials. Asphalt binder is a petroleum product, very expensive, and in some ways it's not renewable. Aggregates, again, aggregates are fairly cheap, but they have to be trucked from a quarry or a pit that's often far away. Surface course aggregates can be even farther because they have to be have special qualities that prevent them from polishing so that you have skid resistance. And I don't think so much in California, but certainly places like Toronto, you're trucking your high quality skid resistant aggregates over 100 kilometers, which would be 60 miles, sometimes 200 kilometers in the Toronto area, because the aggregates you have in Toronto polish and don't provide you skid resistance. So obviously there's challenges that way, not from the environmental side of it, but just running out of those aggregate resources that are suitable. There's lots of aggregates, but are there aggregates that's suitable for the purposes that we need them for? The greenhouse gas reductions in terms of less transportation and other aspects as well in the process. There's energy savings through the production, transportation, and placement of the materials compared to the conventional hot mix and mill and fill. Another important one is the reduced traffic delays. Again, hot-in-place recycling does it, it's a train, but it does it all there on site in one operation. You also have higher production rates, so it's moving down the road faster than a conventional paver. Obviously the reduced trucking of the materials because it's not going back to the hot mix plant, and also bringing new material to the hot mix plant. And of course, you can't look at sustainability without looking at performance. And this has demonstrated performance comparable to conventional asphalt. There's been a lot of historical use of hot-in-place recycling. British Columbia does a lot of this. Ontario does some of this. And they've done a lot of studies and found that it's comparable in terms of performance. Here's a quick sort of comparison of some of the general savings or comparisons in terms of 35% energy reduction, 35% greenhouse gas reduction, traffic delay reduction of about 40%, new hot mix asphalt reduction of 75%, and a trucking reduction of 90%. So what are some of the challenges, or what is the challenge with hot-in-place recycling? This technology has really been around since 1930, but it's never really gained mainstream acceptance And one of the reasons is some of those technologies were not the best. And here's an example. You've got on the left, you've got a hot-in-place process. There's a lot of blue smoke there. You're burning the asphalt, which is hurting the quality. You're also creating a bit of a safety hazard for motorists. I don't think I'd like to be one of those people on the crew inhaling those fumes and stuff like that. And then on the right side here, you've got a process where you can see the open flame is hitting that asphalt, and that's not good for the asphalt. It's basically burning that asphalt, and that's not good for the engineering properties of that material. Even if you try softening it, because it's burned, it won't give you the desired performance you're looking for. And most jobs don't have this, but it just takes one job in every 5, every 10, and just someone says, I'm not doing that again, or, you know, it sounds good, but it just didn't work. And that's been one of the challenges with hot-in-place recycling. However, technology is improving, and there is now the next generation of in-situ regeneration equipment. This is the JP 6000. It was developed by the JP Group, which is got essentially it's a partnership with the JP Road-Tech group, and also through in collaboration with universities, research institutions, and technical experts from around the world. The JP Group is a Chinese company. However, it's really a collaboration there of many international people putting in, including one of the main technical people there, who's a Canadian. So this innovative and leading edge technology has won 22 awards, including the Chinese National Highway Transportation Quality Engineering Award. So what makes this better? Well, okay, first of all, it's the way it heats the pavement. It uses infrared heating technology versus the traditional method of open flame. This gives you deeper, more consistent heating with less emissions. A second improvement is the smoke and fumes that come off. You can see there on the left, the JP 6000 technology. There's no burning of the pavement, there's no smoke coming off, versus some of, on the right side, you see the traditional technology. Another one is fumes and working temperature. On the left side, the JP 6000, and you can see there, there's no fumes, and the temperature right beside it is, what's that, 105 degrees Fahrenheit or less than 40 degrees, versus on the traditional technology, it's over 50 degrees. And a lot of that heat that's being generated is just kind of flowing out versus being contained under the unit to the pavement. So that's what you want to do, and this is doing it. Recycling depth variance. One of the challenges with the old technology is, you know, it would overheat it or underheat it, and you know, it just wasn't the quality control in there. You get a very consistent depth with the JP 6000. The depth variance is typically less than 5% versus the traditional method where it's about 10%, twice that. Another one is mixing time and the additive variance. Remember I said you're taking the existing reclaimed asphalt material, mixing that with a rejuvenator. Well, traditional technology, it just gives it a 10-second mix, and the amount of additive that can be put in there, it can vary by more than 10%. Versus the JP 6000, it's mixing it for over 40 seconds, That's 4 times as long to give you a much better mixing of the material and the rejuvenator. And then on top of that, the additive, the rejuvenator that's put in there, its variability is less than 4%. So a much more controlled, higher quality process than traditional hot in place recycling. Also, the temperature that is achieved in the product, typically the traditional technology, when it's not burning, or even sometimes when it is burning, the pavement is giving 120, but the JP 6000 is consistently heating to 140 degrees Celsius, so you can get the better compaction in your material. This gives you better, in addition to the better compaction, better bonding and better joints. And I don't know, in Canada, I think maybe because of the colder weather we have in our shoulder seasons, we have terrible construction joints between our lanes and our pavements, and so it's really good that you get that improvement. So some of the additional improvements or reasons for some of those improvements are the heaters, the preheating of the existing pavement before it gets milled up. There's better insulation on those units, and the temperature control. There's a lot of monitoring of the temperature in the equipment that allows adjustments to be made. So the heat at the surface or any burning at the surface is reduced, and you're getting, preventing the burning, but you're also getting deeper heating of the material. If you don't fully heat that pavement, when you go to mill it, if it's not been softened, you're going to start milling cooler material or only warm, not hot material, and then you're going to start breaking down those aggregates. And I know you're just kind of getting into loving pavements, but those aggregates, they have to be good quality. Then there's also, believe it or not, there's a lot of engineering. They're not just scooped out of the ground and mixed with asphalt cement. They're engineered to give a proper gradation. They have crushed aggregates, so they lock together better. If they didn't have crushed, they'd be round and they'd kind of move around, and then you'd get rutting. But also, too, the gradation to make sure everything packs up. That's how the existing pavement was originally designed. If you now mill up an existing roadway that's cool, you're going to start breaking down some of those aggregates, changing that gradation, and not getting all the engineering out of that. So that's not going to be a good thing. The mixing unit, I talked about mixing longer, more consistent. That's because of the metering, and a lot of quality management, so that it's all computerized and high tech, so they can monitor all, see it, make adjustments as any material properties change. And then kind of tied into that is the quality management. There's a lot of monitoring of the process, and there's a data logging system that saves all this stuff. And if you're an owner like me, it's nice, or was an owner, I'm not an owner anymore, I don't work for the Department of Transportation now, but it was always great that, you could go back and see what was produced throughout the day, especially too if you thought there might have been a problem. All that stuff is stored for quality management. So on the bottom there, better quality means longer life and increased sustainability. And it's somebody that worked for a Department of Transportation talks sustainability there. Better quality was one of those things to get that is often overlooked. But if you can get a good quality product that lasts its full life or longer than its full life, that's great. Some of the achievements of the JP 6000. This is a new technology, but it's done a lot of work and proven itself. Over 6.5 million meters squared of pavement rehabilitated in the last 4 years. So in there's been over 600,000 tons of hot mix asphalt recycled. There's a lot of diesel fuel that's been saved in the process because it is more energy efficient. And there's been over 6.5 million kilogram reduction in carbon dioxide emissions. So in closing up here, I'll give you some closing remarks. Sustainability needs to be a key consideration for the management of our highway infrastructure. Improvements are needed to our current way of doing things if we're going to meet the greenhouse gas reductions and that circular economy that countries have made that commitment to. And you know, depending on what president comes in for you next year, maybe there's someone that wants to back out of those things. It doesn't matter. We've still got a responsibility to look at sustainability regardless of being part of a Paris Agreement or not. Through the, I would say, the next generation JP 6000 process, you can find cost savings. I did learn today that governments don't have endless budgets for their transportation needs, so this would be really great if you can do some cost savings in there. But you can support sustainability through reducing the need for new materials, energy use, and greenhouse gas emissions. Reduce traffic delays. Well, anyone that works for a transportation agency knows how people complain about traffic delays. You do the work at night because you can't close the lanes down and do this work during the day. I kid you not. People call you up the next day. I want to complain that I was stuck in traffic. Oh, where? Oh, on highway this. Oh, when was that? It was 11:30 p.m. at night. I was coming home and I got stuck in traffic for 10 minutes. Why would you be doing road construction in the middle of the night when people are in a hurry to get home? And I'm thinking, oh my gosh. And you just got to bite your tongue and you're thinking, well, that 10 minutes you got delayed at 11:30 p.m. at night, that would have been 2 hours if we'd closed the roads in the day. So no matter what you do, people don't like the traffic delays. So let's do whatever we can do to minimize them. And then, I think a really great opportunity here for everyone is the use of the JP 6000 hot in place recycling technology. But it's going to take communication by all of us here to find a way to bring that into our highway infrastructure and how we rehabilitate our roadways. Thank you.